After you memorize this table, you are now ready to learn more functions through computations. Just to recap this table really quick, notice the derivative of your three primary trig functions all have positive functions right here. However, when you take the derivative of the co-functions, they are also all negative on this side. So there is a significant pattern here. If you could remember the positive functions, then hopefully you could attempt to realize there's a pattern with the co-functions and the negative derivatives. So hopefully that helps. Figure out a way to memorize this. If you want, you could put them on flashcards. If you were to put this on flashcards, maybe this would be on the front of a flashcard, and then of course this would be on the back. Let's go ahead and differentiate the following function. Don't work too hard here, but we can go ahead and find this function using the product rule and other identities that you have memorized. Here is a quotient function. So for quotient functions, you might want to use the quotient rule. Now remember, in the quotient rule, you never expand the denominator. There is no reason to expand it. But in this case, it's just a simple simplification. Make sure you conclude your derivative with function notation. So go ahead and switch back to the prime notation. Now, these are also related to the topic of proving an identity. In this case, you're trying to simplify an expression. Notice that when you're proving an identity, most of the time, if not all the time, you're just really trying to simplify an expression. So I'll get you started on some of these. I probably won't finish all of them, but at least you gain a hint on how to simplify expressions or manipulate expressions into something a little bit more concise. So we're going to multiply by a magical 1. And this is a little bit easier to read. In fact, I'm going to put a constant of 5 all the way in front of the limit. And that is part of your limit laws. You can certainly do that. Now, because you could see that the limit of this function does exist, and you could see the limit of this function also exists, we may now write additional limit laws. Notice as x goes to 0, we could also conclude that 5x goes to 0. Now these expressions will simplify, and the final expression is simply 5. So notice you just simplify an expression. You started with that expression. You said it is equal to the next expression. You said this is to have the same value as the next expression, and so on and so forth, until you got to a smaller expression. So you might think the answer here is 5. That's not exactly true. The answer here is actually every step along the way, including the limit notation that you need to write to understand how one expression equals another. Once again, in calculus, you have to be 2 steps ahead when you're talking about limit laws. So make sure you understand that the limit of this function will exist. And then if you take the limit of this function by itself, it will also exist. So we are ready to write limit laws. So here the final expression is 2. Not really concerned about 2, just really concerned about, oh, are you able to simplify an expression to get to another expression and to another expression and to another expression and so on.